Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Hello, in this video we are going to be talking about quadratic functions again. However, this time we're going to approach it from standard form. Before I get started, I do want to refresh your memory on what a y-intercept is. Because most graphs have a y-intercept, there are some that do not, but a y-intercept will be on our y-axis, hence why it's crossing the y. And if you think about that visually, I'll make a little sketch. Any point on the y-axis is a y-intercept. So it's going to be 0, your y value. And that number is very helpful to us, and we're going to learn how to do that. But if you are ever asked for your y-intercept, the first thing you should do is substitute x equals 0 and solve. Usually these solving practices are very quickly. A lot of things that were true in the quadratic functions vertex form video are going to be true in our standard form video. If your a value is greater than 0 or positive, if you remember in that video I said positive people are happy people, your parabola is going to open up. If your a value is less than 0 or negative people are kind of frowny people, so it's going to open down. This has a low point, so it has a minimum at your vertex, where this one has a maximum height. Unfortunately, in standard form, we're not going to see our vertex immediately. We're actually going to have to do some work. So vertex form had the h and the k right there, but standard form is going to look a little bit different. It's going to be expanded out. Y equals ax squared plus bx plus c. So the only things I can gain quickly from this are whether it opens up or down, and I can get my y-intercept really quickly. Why can I get my y-intercept so quickly? Let's think about that. If I substitute 0 for x, my y-intercept so 0 times a, because 0 squared is 0, and 0 times b, that cancels out. So my y-intercept is going to be at c. It doesn't matter what a and b is. Because of how 0 works, my y-intercept is going to be at c. And we can use that for graphing. So how am I going to get everything else? Well, here's where you're going to have to actually kind of memorize something. In standard form, you're going to have to solve for your axis of symmetry. So your axis of symmetry is going to be at x equals negative b over 2a. And if you're typing into computer programs and stuff, they are usually very picky about writing your axis of symmetry as an equation, so don't forget your x equals. Now, if we know our axis of symmetry, right, our parabola is going to be centered around it. So, if we make this value the center of a table, we're going to be golden, okay? So when we make a table of values, 5 numbers is going to make a good parabola. You'll have a number, skipped a box. Okay. I want your vertex to be in the center. Your vertex is going to be on your axis of symmetry. So that means the x part is the negative b over 2a value. So if we can do that, we can get this going and we'll be rock stars. Okay, some places you might see the vertex written like this. Negative b over 2a, comma, f of negative b over 2a. This just means your x is your negative b over 2a and your y is the number you get after you substitute it. Okay, here we have an example, f of x equals x squared minus 6x plus 5. So I do find some people benefit a lot with this type by having some steps. So step 1, we're just going to identify a, b, and c. So a is the coefficient for our quadratic function. So our quadratic term is that x squared term, and the coefficient of that, meaning the number in front of our x, is 1. Our b is whatever's part of our linear term. Linear means your exponent is 1. So our linear term is right here, and our b value therefore is negative 6. And your c is going to be your constant, which is your number by itself, and that is 5. In a quadratic, b can be 0 and c can be 0. These may not exist. They may skip it. That's okay. I'll give you an example of that just as a side note. This would be an example of b being 0. And you might see x squared minus 3x. Here a would be 1, b would be negative 3, and c would be 0. So it's okay to skip b and c, or to have b and c be 0. A cannot be 0 because we have to have an x squared term. If we don't have an x squared term, it's not quadratic. So quadratic must have x squared. Whew, okay, I think I got that, hammered through. Step 2, we are going to find the axis of symmetry, the center of it all, right? So that was that equation, x equals negative b over 2a, and fortunately, we just identified them. Negative, I substituted b in parentheses. Okay, be careful when typing this into a calculator that you don't just type it straight across and then straight in the bottom, because your calculator might do the order you type it in, and sometimes we have miscommunication. So it's better to do the numerator, to do the denominator, and then divide, unless you have a calculator that does vertical fractions. I can show you what I mean. I'm actually going to type it in wrong on purpose. So negative 6 divided by 1 times 2. That's 12. That's 3. So what happened is, anytime you're going to type it horizontally, you need to make sure that you completely group your numerator and you completely group your denominator, so that it understands that you have to do the numerator first, the denominator first, then divide. And now we're getting the same answer. So make sure you're communicating efficiently with your calculator. So here's what we know so far. When we graph this, it's going to fold along the line x equals 3. Okay, great. Step 3, sorry. We're going to make a table of values. With, and I'm going to abbreviate, the axis of symmetry as the middle number. Okay. There's that axis of symmetry. That's our middle number. So we need to pick some numbers lower and higher. So 3, 2, 1. we're just going to grab our calculator. Okay. Our x value squared minus 6, the same x value. Hey, that was 0. Change them both to 2. If you're using Desmos, Desmos has a table feature, but Desmos would have also drawn the graph for you. And we're trying to know how to do this. Let's say if we are stuck without Desmos, or in your future college classes where you will not get that. Or just so you can be smarter than the calculator, right? So you can make sure it doesn't make a mistake. There's that symmetry coming out. All right. Now, not only did we make an axis of the table of values with our axis of symmetry, we have subsequently been able to find the vertex. And it's right there. Now, if a problem just asked you to state the vertex, do you have to make the whole table? Absolutely not. Do you still need to find the axis of symmetry? Yes. Okay, after you've done those 4 steps, I think it's pretty safe to say that you will be awesome at step 5, which is making your picture. All right, so 3, -4. I am going to mostly do this on the right side since we didn't use many values to the left. And I like to draw my axis of symmetry, and it's just a nice vertical line. Remember, that's an x equals equation because it crossed the x-axis, crossed at 3. We had 3, -4 as our vertex, 2, -3 in symmetry, 1, 0, and there was our parabola. Can I count? No, I cannot count. There we go. I knew something was a little shady about that. You were probably yelling at your screen, right? That was only down 2. Okay. We have our domain. By the way, if you're asked the domain, it's pretty safe to say it's -infinity to infinity. Unless there is something in the equation that causes domain errors, your domain is probably, if you ever have to just randomly guess, say it's all reals. The reason why it's -infinity to infinity is it continues to the left, it continues to the right, there's no gaps, there's no breaks. Our range, however, has a floor or a bottom number of -4, and it continues up from there. Now you might be asked to go from this back to vertex form, but here's the great thing. You already know that your a value is 1, and your vertex is 3, -4, which means going back to vertex form, a x minus your h value plus your k value. And to pretty that up, we could just say, so if you know the vertex getting vertex form, you're a rock star. It's not a big deal. Oftentimes in algebra, we get given 3 random points for a parabola because you'll need at least 3 points to determine that parabola. And we are asked to just find it. If one of these were the vertex, it would be easy. We could just put the vertex form in and use a second point to solve for our a value. Unfortunately, that's not the case here, so we have to look at this from standard form. So that standard form is going to be ax squared plus bx plus c. We happen to be given the x values and the y value. So to do this, first of all, I'm going to have to substitute each of the equations in. To make this nicer for me and to make it to where the students normally like it better, I usually go ahead and flip this. And write the reflexive version down. It just happens to make some people feel better. Remember, we are substituting for the x's and for the y. So equation number 1, that's that ordered pair -5, -35, right? A times our x value squared plus b times our x value plus c equals our y value. -5 squared is 25, so I could write a times 25, but I'm going to write 25a. b times -5 is minus 5b. So that was ordered pair number 1. You might notice that we have 3 variables, a, b, and c. If you've watched other videos, you might know where this is going now. So our second ordered pair was 4, 1. So we have a times our x value squared plus b times our x value plus c equals our y value. So 4 squared times a, b times 4, and our third ordered pair was 7, -23. So a times our x value squared plus b times our x value plus c equals our y value. So a times 7 squared, that would be 49a. Okay, so we have 3 equations with 3 unknown variables, meaning we have a system of equations with 3 variables, which means we are going to need to target something. And if you remember when I talked about the targeting video and utilizing elimination, I like one of the variables to have the same coefficient, which c is a +1, a +1, and a +1. But I wanted the middle one to have the opposite sign. That way, these would be additive inverses. So right now, this is a +1. When I rewrite this group of 3 equations, I'm going to rewrite it, but I'm going to multiply this row by -1. And if you haven't watched that systems of 3 equations, you can go back and do that, or maybe just it will pick up and refresh your memory as we do this. So I'm going to write down the top equation. I'm trying to write really tight so I have space across the paper. Remember, I'm writing this down, but I'm multiplying it by -1. All right, now we're going to take the top equation and the middle equation. 25 plus -16 would be 9. -5b and -4b is -9b. Plus c and minus c cancels out. And -35 and -1 add to -36. All right, -16 and 49 is 33a. 7b and -4b makes +3b. Positive c and negative c cancel out. And -23 and -1 make -24. Okay. So I'm going to do something unusual. Instead of multiplying them up to get the same number, I'm just going to show you a trick that sometimes you can go smaller to get the same number. I notice that everything here divides by 9. And I notice everything here divides by 3. And if I do that, my b value will start with a 1, and I'll have smaller numbers. So that's a fun trick you can sometimes use. I just thought I'd point it out since it popped up in this example. So technically, if I'm dividing by 9, I'm multiplying this entire row by 1/9. And dividing by 3 means I'm multiplying by 1/3. So I'm still using a scalar. I'm still multiplying by something. I'm going to write the pink and the blue back down here. So dividing by 9 will give me 1a minus 1b equals -4. Oh, small numbers. Okay, dividing by 3 or multiplying by 1/3, 11a, 1b, and negative 8. Now when I do that, I will go ahead and I will put those two lines together. 1a and 11a makes 12a. And negative b and plus b cancel out. Negative 4 and negative 8 is negative 12. I can divide everything by 12, and I'll find out that a equals negative 1. Now that I've done that, I can go back and substitute and find my b value. I'm going to go ahead and take this dark blue here. 11 times negative 1 plus b equals negative 8. That's a negative 11 plus b. So I'm going to add 11 to both sides. That way the 11s will cancel out. And I find out b equals 3. Last thing I need to know is c. I'm going to come back up and I'm going to use this Brown equation because it has positives. Everything on the left is positive. So 49 times a plus 7 times b. Whoops, I forgot to put my 3 in. Plus c equals negative 23. Slide that up. So we have negative 49 plus 21 plus c. That's negative 28. When I add 28 to both sides, I find out c is 5. And we're not writing this as an ordered triple like we did in previous videos because I know we have the a, the b, and the c value. But the reason we had the a, the b, and the c value is we wanted an equation, right? We wanted to fill in the a value, the b value, and the c value. So our answer is negative 1x squared plus 3x plus 5, or negative x squared plus 3x plus 5. Again, if they had given me, the y-intercept, it would have been helpful, the vertex, it would have been helpful. But if they just give me 3 random points, I have to take the long way. If you know matrices, or if you've done the matrices video, that actually is really nice as well. But these are you just kind of have to pound through it. So if you have questions, again, please let me know.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.